So in this video, I'll be talking about how you get the bubble and dew temperatures and creating plots of the bubble and dew temperatures of the two substances, methanol and isopropanol, from having the pressure at a 101,325 pascals. So I already had this installed. Delete that, it's not important. Which the main things we need is ChemTool, JAX, Plotly for plotting, and from this website we get methanol, isopropanol data and the properties of them, and we need VSC. So Shift Enter. The first thing we need to do is define a bubble temperature. So define bubble T. We need to put a semicolon, and then we need to return what we want, which is the partial fraction. Well, it's not the partial fraction, the partial pressure. So J, we're gonna need an array. So JMP dot array, and first we're gonna need P dot pvap C dot T, which we'll define later in the model. We need the mole fractions, C dot X, which will be later defined in the model, and we divide it by C dot P. Make sure I got all the parentheses right, and I believe that is, and we need to subtract it from C dot P. And then we make the dot map values, so dot map C equals map. So you get C dot X equal to JMP dot array of, let's say, 0.3 and 0.7, parentheses around it. C dot P is equal to 101,325, which is regular atmospheric pressure under normal conditions, and then C dot T is equal to, we're going to have a range, so let's just set at 300, 200, and 700. And then we do VSC equals VSC of, so pretty sure it's a model. So let me do it again. Pretty sure it's bubble T C. Get VSC dot solve is equal to verbosity 0. Shift Enter, and we got an error with the dot map, which is because there wasn't supposed to be a colon. C equals dot map. Dot map is not defined. Saying dot map. Oh, it's saying the top thing isn't working. Let's give this a shot. Okay. Now we got VSC. It's probably backwards. C bubble T VSC solve verbosity. So vibrosity, let's see. It says it's an array. That's why it wasn't working. JMP.sum, because we're trying to get the mole fraction and the partial of the two components. So the sum of the mole fraction and the partial pressures of the two components. So when we run this all again, okay. And it still says, yeah, no wonder, because I don't need this division. That was a C with apostrophe, which screwed everything up. Just the simple errors. And look at that, voila. Because that's what we want. And then I do VSC dot V dot T. It gives me 349. I'm going to do the same thing for the dew temperature, essentially. So, let's just say Control C, Control V, change it to dew. Shift Enter. Control C, Control V, Enter, and then VSC.V.T. So there are going to be a few things different, mostly inside this. I believe instead of minus n, we gotta first we had C.Y, so that is something we gotta change here. C.Y. So mole fraction. So that gives us the mole fraction of the liquid. This was the vapor. Oh, actually, it's not the liquid, it's the mole fraction of the dew. That's some more term we want to use. So C.Y, we times it by the overall pressure now. And then we divide it by the C, not the C, the P dot P vap of C dot T. I want to make sure this is all in parentheses. And this will give us the mole fractions of X1 and X2. Do that. And then we got an error, unexpected parsing. First I want to do. So that's obviously a problem. And it got rid of the parentheses outside for some reason. Yeah, okay. And this gives us, well, I messed it up because it's not bubble T anymore. It's dew T. So that is going to change some things here. Let me start from the beginning. That 699 is definitely not right. It probably has to be somewhere in this equation. So it gives us our mole fraction that's much greater than 1. Subtract 1. Now that is a value that seems correct. So, but the problem is this is only giving us one value, and you can't just plot one value on a graph so we can see what the curve looks like. So we're going to have to make an array of bubble temperature and dew temperature. So to make this array, we do, what should we name it? Mole fractions is equal to jmt.linspace. Let's go. What should I do here? Let's start at 0, 1, 12. And this will give us 12 values, so 12 rows of values. Because we're doing it from 1 to 12, starting at 0. So, and then we can just copy and paste our bubble temp and our dew temp. So with this, we're going to have to do do only have one C dot map in here. I guess I didn't put one there. Okay, let's put another space. Define, solve, dew, T, and solve dew T. Let me see. C. And then we want to define solve bubble T C, and let's just space these all out, indent them. Actually, I don't want doing it. We are going to have to change some things since we actually aren't going to have, that's what the array gives us, the mole fractions here. So for the mole fractions, we're going to have to, instead of array number, it's going to be the first mole fraction in the bubble times pressure and the second mole fraction. So liquid or dew here in the P with the same pressures. Well, actually that's not right. This should be 1. This is finding the mole fraction, so it should be 1 minus actually y1. And up here it should be 1 minus x1. Instead it's not there, it's x1 and p and y1 and p. So run that, invalid syntax at define bubble C, and I don't have colon mark as usual. That's usually my biggest mistake. So we got both, but we're not finished here. You have to return these values, which I didn't do, which I'll do later. And we also have to put them into an array, so then we can divide, because you can't divide you can't divide like a single matrix by a, let's say a 2D matrix, 3D, 4 by 4, it won't work. So first let's return the values here. So return vsc.v.t. Actually, let's see. Put that here. Actually, no, that was actually good where it is. Control V. So now we want to solve. So let's say solve bubble T. Let's just say what I said earlier: 0.3, 0.7. And let me do another one. Oh yeah, see. Let's see, is that the same number as up before? I believe it was. Yep, 349.05, 349.05. Then solve do T 0.3. Well, actually, it shouldn't be 0.07. That's my bad. Yeah, like it should be the same pressure of 101.325. And this is 351.57. Yep, the same number. But now we want an array of values, so we can have a list of values that we can actually graph. So we're going to do solve bubble T now equals jmp.array. This is solve bubble T array equals jmp.array. So now we need to create a list. So to do that, we do solve bubble T for x1 in mole fractions. And what this will do, it will give the bubble temperatures of all the index values from 1, 2, 3, 4, and what I did earlier. So where did I put it? I'm pretty sure I did it to 12. So where's my one space? JMP. Yep. From 1 to 12, it'll give me all those values. I do the same thing, so let's Control C here, Control V, solve bubble, do T array, solve do, and I'm gonna need the same 0.3, 1325, actually it won't be 0.3. Just be y1, and then for this it's the same thing, x1 101.325. Let's see, an error, and there is another thing I forgot to put it. Well, I'm gonna do it brackets. That's the error here. I'm gonna have to stop here and go to a new video.